Hello, this is Ms. DB, and in this video we're going to continue working with Chapter 5, Section 3 on solving quadratic equations by graphing and factoring. And we will continue what we worked on in the last video, plus determine a quadratic function from its roots. Alright, so in the last video we talked about how to factor so that we could find the zeros of quadratic functions. Sometimes when you do that factoring, you will need to use one of these special products and factors, or you can anyway, to make it a little simpler. So we learned about these in Algebra 1. We had the difference of two squares when you'd have something squared minus something squared, like maybe x squared minus 64. You could factor that as x minus 8, x plus 8. Or you could rewrite this as x squared plus 0x minus 64, and then you could factor trying to find the factors of negative 64 that would equal 0 when you add them. Note that this is the difference of two squares. It's not possible to factor a sum of two squares. If this is a squared plus b squared, like x squared plus 64, you could not factor that, and you would just be done with that problem at that point. We also discussed perfect square trinomials in Algebra 1. That is where you have something like this, x squared, let me put this in first. So this would be plus 8x plus 16, where this factor of the square root of 16 would be 4. If you took 2 times 4, you would get 8, which is where this number here. So if you have one that is in this form, you can use the methods of factoring that we've already talked about, or you can recognize that it's a perfect square trinomial and factor it a little bit quicker. So these are shortcuts. They're not necessarily the only way to factor these, but if you recognize that it's one of these two types, then you can factor it more quickly. All right, if you are asked to find the roots or the roots of an equation or the zeros of a function, sometimes it would say zeros. So it might say one of these two things. By factoring, then you have to set it equal to 0 first, even if it's not a special kind of factor. So I'm going to subtract 25 from both sides, which leaves it equal to 0, which I want. Do that no matter what kind of equation or function you're given first. If you are given f of x equals 4x squared minus 25, then you just replace the f of x with 0 and continue. But if you're given one side equal to another side, then set it equal to 0. Then we will continue from there. And in this one, they're saying, well, hey, this is something squared minus something squared. So you need to figure out what is being squared in each part. And they said, well, if we took 2x and squared it, we would get 4x squared. If we took 5 and squared it, we would get 25. So it's in the form a squared minus b squared, which means then that you can factor it as the special factor of a minus b, a plus b. So you'll still have two equations, two unknowns, and you'd set them each equal to 0. And you'll get two different answers. One will be negative 5/2 or negative 2.5. You could write it as a decimal if you wanted. And the other one would be a positive 5/2 or 2.5. You can always graph these to check. It's a nice, fast way to check. And they, instead of graphing after we set it equal to 0, they could have graphed, where were we? Right here. They could have graphed 4x squared y equals 4x squared minus 25. Or they could have graphed f of x equals 4x squared minus 25. Instead, they graphed this side and this side on the same graph. So they graphed y equals 4x squared and y equals 25. The intersection of those two would be the solutions or the zeros of this graph. Okay, so this one is not yet equal to 0, so that needs to be our first thing. Second, look for anything common that you could factor out of each of these. 6 times 3 is 18. 6 times 8 is 48. But 8 times 4 is 32. Well, they definitely each have a 2 in them. Do they have any other common factors? Just a 2. So you factor the 2 out, write it in front, and then write what you would have remaining after you factored the 2 out of each term. Then we want to look at what's left. This is a complicated one unless you realize that it's in the form a squared minus 2ab plus b squared. If you recognize that, let's see, if I took the square root of this, I'd get 4, and if I took the square root of this, I'd get 3. So 3 times 4 is 12 times 2 is negative 24. So now you can use the special factoring, the perfect square trinomial rule, shortcut, and it would be 3x minus 4 times 3x minus 4 equals 0. You can set both of those equal to 0, but you're going to get the same thing on both sides. You're going to get 4/3 or 1 1/3. So there's only going to be one point where this graph touches the x-axis. They're checking it by plugging that number back into the original equation, and they found that you get the same number on both sides, so that means it would work. Here's some problems from your worksheet. I think I cut one of these off, but you would first make sure that it's either in f of x equals x squared minus 1 in that form, or you need to solve for 0 and write it in standard form. Like number 9, let's get this equal to 0 by subtracting 12x from both sides. And then we would have 0 equals 9x squared minus 12x plus 4. Now it's ready to factor. Now because we're in the section on looking for special factors, check and see if maybe this is in the form of the perfect square trinomial or difference of squares and factor from there. And then set it equal, each equation equal to 0, and solve and see what your x is equal to. This one, remember, you would have to set this equal to 0 first and then proceed. Let's do number 11. In number 11, it's already f of x, so we can just say we're going to set it equal to 0. It looks to me like we could rewrite this as plus b squared, this form, because we could write this as 2x squared minus 2 times a, which would be 2, and b, which would be 5, plus 5 squared. Let's see if that works. That'd be 4x squared minus 4 times 5 is 20, plus 25. Yep. Oh, I forgot the x here. There's the x. And that means that I can use the special rules for factoring, which says that you'll use the a minus b times a plus b. Or is it a minus b times a minus b? There we go. So now let's check this. 2x, always FOIL back to check. And 5 and 5 and minus and minus. And let's FOIL back and make sure that this is going to work. So we would take first times first is 4x squared. The outer would be minus 10x. The inner would be minus 10x. Whoops. And the last would be negative 5 times negative 5 is 25. And when we add our like terms together, we'll get negative 20x there. So that works. So now I have to take my 2, don't forget to do this last step, I have to write that those are equal to 0. Now they're both the same, so you don't actually have to write that twice. There's only going to be one point that is a solution to this, and that is at 2.5. So when x is 2.5, or 5/2, then that would be the 0, and you can check this by graphing, and we'll see that this would be a graph where it's only going to touch the x-axis at one point, and that point will be at 5/2 or 2.5. All right, now we are going to do one more thing, and that is if you know the zeros of a function, you can work backwards to write a rule for the function. So let's say that we know that our zeros are at 4 and negative 7. So let's sketch what that would look like. Here's 4 and here's negative 7. So I have a graph that is either opening downward and going through those, or maybe it's opening upward. and going through those. I also don't know how fat or how skinny it is. I don't know where the vertex is. But I can write a function that would work. It will not be the only function, but it'll be one. So here's what we do. We write the zeros as solutions, x equals 4 or x equals -7. And now write the equation that if we backed up a step, this is what we would have had. Basically, set these equal to 0. So subtract 4, add 7, add 7. So that means either x minus 4 equals 0 or x plus 7 equals 0. Well, that means that what our two functions or our two factors were these. So write those next to each other. Then our last step is just to multiply these together with FOIL. First times first is x times x is x squared, plus 7x minus 4x, inner times inner. And then the last times the last would be, it's a -28. So add your middle terms together and you get 3x, 7x minus 4x. And here is our a quadratic function that would give us those zeros. And you can graph it and check. And then they said take the 0 away and put f of x. So now we have our actual in function notation, our answer. And you can graph and see that that indeed would give us zeros. This is an opening upwards one of 4 and -7. Now again, this is not the same, this is not the only one that would work. They give us some examples that would also work, but that's okay. These are all ones that have 2 and -1 as zeros. But it's one function that would work. So here we have zeros equal to 1 and 2. So we subtract 1 from both sides to get x minus 1 equals 0. So set both of these equal to 0. And then we're going to, for a, write the factored form of the function. So the answer for a is to take these, put them in parentheses, multiply them together. And that's the factored form. You can write that it's equal to f of x now. If we multiply the factors, we'll get the quadratic function in standard form. So you would FOIL these together. First times first is x squared minus 2x minus 1x inner plus 2. And this is our quadratic function in standard form. Finish this up by combining our like terms in the middle, and that would be a function that would give us the zeros of 1 and 2. Note that in 14, your zeros, one of them is negative. So we would add 2 to both sides and get x plus 2 equals 0 as one of our factors, and x minus 3 equals 0 as our other one. And that's it. This was a shorter video, and please let me know if you have any questions or concerns, or if you want to meet together to finish this worksheet up. Thank you very much, and have a great day.